topic of this first session is to give an overview on the SIOS Data Management System and then dig into more details of the data management plans. I think that was the overall topic. On a more general part of the outline, so the way I've organized this now is that I will go through the SIOS Data Management System, an introduction to that, just to give some background and context of why we do the other things here. Then we will, of course, mention FAIR data, the science workflow and the data lifecycle, and how to publish data. Some elements on expectations on scientists, so what you have to do in order to publish your data in a proper manner. And I've set up then a very brief overview on some nonce legacy tools that could be of interest to people here. I think that if there is some voiced interest in these tools, we could actually dedicate a specific training session to those tools. So I will just briefly present them during this session. And then, of course, it's the data management plans and various tools to work with them, which focus on the purpose of data management plans and link you to a number of services that you can use in order to set up data management plans. Part of the background for what we do here is, of course, we need to change the data sharing culture within the community. And this is a nice photograph that a colleague of mine took in the American Meteorological Society conference in Seattle some years ago, which basically means that you need to guide people through these data sharing and data publication efforts. Most people need this guidance, illustrated by the donkey and the people trying to move it in a certain direction. And then, of course, some people are more or less self-contained. They have all the tools they need, all the equipment they need in order to do this. And they can do it on their own without any support in this context. Briefly on the SIOS Data Management System, this is a core effort of SIOS, and it's built on integration of existing data centers into a unified system. So each data center, primarily hosted by the SIOS partner, has its own procedures and technical solutions tailored to the needs of that data center. SIOS is not changing this, but is trying to bridge between these data centers. And the way we bridge is using internationally accepted interoperability standards and technologies. We do integration through a dedicated working group, which involves all partners with data repositories. And the implementation is done through the SIOS Knowledge Center. And there is an illustration on the right-hand side that just outlines this effort. The approach that we are following is that the SIOS Data Management System is built on a dataset-oriented approach, meaning that it's the dataset and the definition of the datasets that's critical for the performance of the data management system, and the ability that the user has to filter out the relevant information that they need. It has an open data space, meaning that SIOS is spanning multiple disciplines and communities. So we do not constrain the mechanism or the definition of what a data set is, but that's quite open in this context, so that we're able to consume upcoming and future types of data into the system. It's also net-centric, meaning that we have not a centralized system, but we have a collaboration of data centers working together in this context. And it's interdisciplinary, as I did mention, so it's dataset agnostic. The basic principles and the priorities of development of the SIOS Data Management System can be sort of linked to the FAIR guiding principles, which we will come back to later. But the first and most important part is the usage of the ability to find relevant data sets. So I won't go into details of the technologies, etc. here now. That is something that we can dig into if there are any questions on it. But, and primarily the discovery metadata is a challenge of the contributing data center. And it's something that the scientists discuss with the contributing data center. and the contributing data center discuss with the SIOS knowledge center in the sense of integrating across these data centers. So first of all, we do focus on finding the data. And in order to do that, we have a search model that is based on GCMD, that is the Global Change Master Directory science keywords. And this is more or less legacy of the International Polar Year. And the reason why we chose the GCMD science keywords is that those cover a number of disciplines. So it's not necessarily discipline specific. So what is the keywords in this context? So the keywords is basically a controlled vocabulary or an ontology that we are using in order to properly tag the data sets that we serve through the system. So I won't go into the details here either. The important message here is that if you want people to be able to properly find and filter out the relevant information, we need to agree on a common set of keywords that we are using to describe the data that we are working with. And specifically in the context of the SIOS data management now, it's the element of the Earth system, also the Earth science keywords within the GCMD keywords. And this category of keywords has a hierarchical structure which relates to atmosphere, ocean, cryosphere, and a number of biosphere, etc., a number of disciplines. And then you have terms and variables of the different details throughout this system. So if you have gaps or there are keywords missing that you would like to use, you just enter up at a higher level in the hierarchy when you tag your own data, when you submit them to the data center that is affiliated with the SIOS data management system. And of course, we need to work on the data submission through the existing data centers, because the data is not hosted locally in SIOS, but it's hosted by the contributing data centers. And the model for SIOS is based on long-term preservation through the mandated data archive. So the data centers that are actually contributing are supposed to be have a long-term mandate and mitigation plans in case of any trouble in the future with the sustained operation of the data center. So in the short term, the functionality that we are looking at is data discovery through human and machine interfaces and simple retrieval of the data in the form served by the native or the host data center. So this thing is already working today. In the long term, we need to work harder on data visualization and data transformation services. This works to a certain extent today within the SIOS data management system, but only for those data sets that fulfill the requirements in order to be properly visualized and served through the system. And this calls for this functionality is based on requirements both on the encoding of the data, but also on the way data are served over the internet. The existing setup that we do have for the SIOS data management system is that we do have a centralized service that is actually harvesting information from the contributing data centers. This information is made available through the SIOS data portal, which is hosted in the SIOS web page. And the way we are doing this is that we are on a daily basis, we are harvesting information from the partner repositories, which are listed on the left-hand side here. But we are also harvesting information from non-affiliated sources, but that we do know have information that is relevant for the SIOS community, meaning data covering Svalbard and surrounding areas. Among the partner repositories, we are harvesting information from selected projects hosted by Pangea, so that is primarily the Arvid repository in this context. We are harvesting information from the Norwegian Marine Data Center hosted by the Institute of Marine Research in Norway. We are harvesting information from the Norwegian Meteorological Institute. We are also harvesting or getting information from InfraNord, which is served through the NIRD, National Infrastructure for Research Data in Norway. We are developing the integration of the Italian Arctic Data Center, hosted by CNR. We are harvesting information from the NILU, also the Norwegian Institute for Air Research in Norway, the Arctic Data System in Japan, hosted by NIPR. We are also harvesting information from NERSC and from the Norwegian Polar Institute in Norway, as well as the Polish Polar database, hosted by the University of Silesia in Poland. In addition to these integrated, also the partner repositories, which we call them in the context of SIOS, we do also harvest information from China, from the Polar Research Institute in China, from the National Snow and Ice Data Center in the US, the Polar Data Catalog in Canada, from the British Antarctic Survey in the UK, and the World Glacier Monitoring Service as well. The level of interoperability of these catalogs differ. So usually it's rather mature interoperability at the discovery level and rather poor interoperability at the data level. So when you dig into the actual data. The way that we do harvest this information is that we do an incremental harvest every night, and once a month we do a wipe of the database and we do re-ingest all the data. And the reason for this is that sometimes data sets changes and are replaced by new data sets or deleted or other things. And without this mechanism, since people are using different systems for connecting to the SIOS Data Management System, without this functionality, we would end up with a large number of stale data or dead data sets in the system after a while. So that's why we do this wipe, regular wipe in the system. Sorry. The thing that is powering the SIOS Data Management System is the principles that are outlined in the SIOS data policy. And I won't go into details of this data policy. Everybody can reach it through the SIOS website. It's based on the principles outlined in the international, also the IPY, International Polar Year Data Policy. Also the ISC data policy, and the principles outlined in the EU regulations in this area. So this is just the table of contents for the data policy. Some things that are quite important is that the SIOS data sharing principles are full and open exchange of data, metadata, and products. So this is quite important and in line with the normal procedure for such data policies. Same with the availability of the data sets and the costs for sharing the data or accessing the data. But one important thing is that, and this is quite instrumental in the way that modern scientific data sharing works, is that every user of data supplied through the SIOS Data Management System should, or must actually, acknowledge in any publication or other derived work the contribution made by those that actually created and worked up the data that they are using. So this is to give credit to the attribution to the data providers in the system, and this is also in line with the recommendations of the ICSU World Data System and other frameworks for this purpose. It's actually an element that is in the process of being worked into the upcoming updated data policy of the WMO as well. And then I will just briefly go through the SIOS catalog search interface, how it works today, before we dig into the FAIR data and how to work with FAIR data. So I think that perhaps we can have some questions if you have questions following this tour through the catalog search interface. So currently, what I do now is focus on the interactive search interface, which is embedded into the SIOS web page. In addition to this, we have machine interfaces that could also be the topic of a specific training session later, because I need some more knowledge in order to be used properly. So the SIOS data portal or data access point is available through the access menu in the SIOS web page, where you have the data part. And once you push that menu choice, you end up in a page that looks like this, where I have collapsed all the menu items. This thing or this interface will look different in a month or two, or some months, because we're actually upgrading the whole interface to the catalog system this spring. So that's the principles still are valid, but the appearance of this page will look different in a couple of months. First of all, you have the full text search. There is also the ability you have here is to search full text, meaning you can put a keyword and search through the whole contents of the data sets that we have in the index or the catalog system. Then you can do a temporal search. You can constrain the temporal period for the data set. You can constrain the spatial extent of the data set. You can look for institutions that have provided the data. So these are the institutions of the principal investigators behind the data sets. Collections is a specific thing that I will come back to. It's something that is better explained when I look at the menu choice for this. And of course, you can ask for the investigator, the principal investigator of a data set. And this is not a controlled vocabulary, so this depends on how people actually spell and write their name. So that's something that we can come back to. And last, we are using the topics and variables that you have tagged your data with in order to give the information relevant for various disciplines, which I will also come back to. In the search interface, in the full text, this is like a free text search that you do on Google, for example. It allows you to search for any phrases within any part of the discovery metadata that we do have. And I will also come a bit back to the principles of discovery data and how they work. In this field, it's important to know that you are able to use logical operators like and or, so that you can actually have mutually exclusive words that you're looking for, or a combination of words. This can be quite powerful for advanced searches. The next thing that you can do is to constrain the data collection period. For the time being, we only have a start date and end date, and this complicates the issue for some of the data sets. Some of the data sets do have multiple time periods they are spanning, and we are not able to handle that currently. Not everybody that we are harvesting information from are neither handling this properly. So for the time being, it's just one time period that you can identify. And normally, for some data sets, this will contain several independent time periods throughout the data set. The spatial constraint that you can put out, the bounding box, this is quite easy to do in the sense that you can point and click on the map. Then the information from the map is filled into these boxes in the spatial search, and you can refine them manually if you like to do that. So if you want to do a very specific area or spatial query, then you can actually use these boxes to give more specific information than what you are able to do in the map interface. The institutions list here, as I mentioned, you have the institutions of all the principal investigators that have contributed data into the system. And by ticking off one of these boxes, you can get all the data in the system that originates from this specific university. This is one of the elements that we are making faceted in the next version of the system, so that you will get a list on the side of the the page where you can get all the number of data sets for each of these institutions. So that will change slightly in the next version of the system. Collections is something that we do use in order to segment the content of the SIOS Data Management System into subgroups. Sorry. The current setup here says that we have the SIOS tag or the collection tag. And this is basically the all data that are served through the SIOS Data Management System have this tag. So those are data, whether from partners or from third parties, that are of relevance to SIOS. We do also in the SIOS Data Management System host the data collection from the Norwegian project called Nansen Legacy. So this is actually the tag AEN in this context, which have activity around Svalbard. Then we have data sets linked to the CES reports. So you have the data sets that are linked to the CES report for 2019, the CES report for 2018, the CES report for 2020. And we have data sets that are linked to the SIOS access programs. In order to put these tags on the data, we do rely on the tags added by the contributing data center in this context. Sometimes people do enter information into the SIOS Data Management System using the metadata entry form that we support in the system. Then we maintain the discovery metadata internally in the SIOS system. Then it's not a problem. But if you actually put your data through a partner repository, you have to make sure that the proper keywords are added to the data set when you host it in your system. And this is something that we address through the SIOS Data Management Working Group. So yeah, the important thing is to remember to tag your data properly when you submit them to a data center that is affiliated with SIOS. Investigator is just a free text search looking into the personnel tag in the metadata. So it's basically the name of the principal investigator, and we have no controlled vocabulary for this. So typos, etc., will be conveyed through the system. So there may be challenges with how people write their name when you want to search for a specific person. The good idea here is to just use the last name, for example, when you search, and try to write different manners of the last name when you search through the system. The last part here is the ability to filter between disciplines in the system. So, for example, if I'm looking for information about snow in the system, I just start writing snow into the system, and then the keywords that are related to snow will pop up in the list below. You choose them, and then you push search, and you should get all the data sets that are linked to snow, for example, in the data catalog. There is some challenge with this approach, meaning that not everybody is actually serving this information as GCMD sign keywords. Some data centers only use free text fields and not a controlled vocabulary. Still, the word snow should be available through a number of those data centers. But we do have a challenge in this context. And the lesson learned from this is that it actually matters how the quality of the metadata that you put on your data when you submit data to for publication through a data center actually matters. It directly affects the ability of the users of the system to filter out the relevant information. So please do take care when you tag your data in the system. Yes, just to show you how it could look like here. So I was now wondering about, I want to know something about weather, and I want to know if there is some information about weather at the station called Verlegenhuken. So that's a station in Svalbard. So as you can see, I put in the information into the search system using the logical operator and. So I want to find information about weather and Verlegenhuken. And then it's quite easy because you don't get 1,000 records that you have to manually parse through, but you get one observation that is put on the map here, and you have the information listed below here as well. So if I now push on the additional information button that you can see here, I've selected the station I would like to look at, pushed the additional information that you get, then you get this menu that we have down here. Now you can choose to look for additional metadata. You can look at data access, or you can do a visualization or a download of the data set. So these data are actually served as NetCDF CF, but if you want the data as ASCII, you can get the data directly through a transformation service that converts the data into an ASCII file that is a comma-separated file. If I push the additional metadata button, I do get extended information about this data set.
Sorry, Øystein.
Yeah?
There is a question in the chat box. Can you zoom a little bit your screen? Because it's really hard to see the...
So this is actually a presentation. I do have a problem with zooming, but we can go through it afterwards. If I can just push through this, I can bring up the web browser and go through it afterwards. Yep. Briefly.
Okay.
Is that a solution? Okay, so then I will just skip quite fast through this. But here you have some extended information about the metadata. And if I then push the visualize button, I get a graphical interpretation of the data, and I will come a bit back to what we can do and can't do with this. The important thing here is that you can actually do a number of things on the using the menu at the top here. So if I do the same like we did before, now you see I have the same phrase that I was searching for. I have a logical combination of two words that I'm looking for. Push enter. I get the map. There is only one station in this. You have a pagination of the results at the top here, so you can go through the pages if you like to. If I push this one, I get a menu below here where it says, okay, this is the landing page. Basically, this button shows the landing page for the stations or the observations from Verlegenhuken. And if you can see briefly at the bottom of my down here, if you look carefully when I have the mouse over, you see the address to the landing page for these data. I can, of course, download the direct file. Also, if it's only one file, I can push download here, and I get the data direct for download. But I can also push this additional information. Oops. Just need to be on the correct part. Then I have this information below here, where we have the further information about the data set. I can, of course, push data access, and I know that this data set I can collect through HTTP, and I also have the access to OpenDAP for this data set. But if I do push additional metadata, I get the full information about the data set. So here you see that the landing page is available here. I have the data access, as you saw under the data access button as well, with HTTP and OpenDAP access. You have information about the data center hosting the data, and you have the keywords that are attributed to this data center. And actually, dataset production status tells us something about whether this is a complete data set or it's a data set that will be extended into the future. And if I would like to do a visualization of this data set, I push visualize here because the button shows up. If the button doesn't show up, there is no possibility to do on-the-fly visualization of the data set. So here you have the variables in the data set. I have surface air pressure at 2 meters. I've got relative humidity, the wind at 10 meters. I've got air temperature, wind speed, air pressure, etc. So if we look at the air temperature, it goes and reads the data. Hopefully, this is always a bit anxious or interesting when you do a live demo. You get an illustration like this. And here we can go in and we can look at the specific areas. And you see when I do a mouse over, I have the exact dates for this in the time series and the value of the variable at that specific time. So this changes a bit. I can, of course, also say that I'm not interested in, I'm only interested in the, oh, sorry. Let me see, this is sometimes a bit awkward. So, should work like this. I say that I'm interested in only this period. I can zoom into a specific period and I can do the same things. And of course, I can also say that I would like to save this information. And then I get a PNG image that I can download and continue to work with. So you can do change. So the important thing is if you try to work with this and change variables, etc., just push the reset button, then you get the full data set again. And of course, it depends. Since this is done over the internet and it connects to the host data center, it may take different amounts of time for different data sets when you look for it. Also, we don't have control over the load on the servers that are serving the data. And this is just changing to the relative humidity and how that works. So basically, this is something on the fair data. So we have to go through the buzzwords. This is also so that you understand the concepts we try to work with in the SIOS Data Management System. This was a new illustration that I found some days ago, or a week ago, I think I actually found it. It's from Denmark on the fair data. So we'll give you the address to this page at the end of this this session. It's quite nice, I think. But it's something that people should be aware of, and that's the process around. Also, you get some source data that you create. You want to process the data, and then you have some results that you would like to publish and disseminate or share with other people. So when I say sharing data is different from publishing data in the sense that sharing data is something that you can do on a hard drive in your own system. You can do it through Dropbox or things like that. But when you publish data, you put data in a context, and that's quite important, important here. However, there is one thing in this setup that actually differs from many of the other workflow diagrams or life cycle diagrams that I've seen, and that's the element. I hope you can see my mouse pointer now. The element on discard data. So it's not all data that you generate that you should take care of. You have to do a careful analysis of what's worth taking care of, both as raw data and store them somewhere, and also as data that you should publish. So that's an important part of the workflow. The data lifecycle and its relation to the researcher's workflow. This is an illustration or a slide that I'm using quite a lot. You have the workflow, a slightly different way version of it, actually more traditional in the sense that you collect, you quality control, you describe your data, you deposit your data, you preserve your data, you discover data, so you publish the data, and then you integrate, analyze, and also, so this is a workflow that actually reuses other people's data as well. So slightly different than the previous one, but still much the same aspects. I think the previous one that you can look at the link that I gave you earlier is also quite useful to use. So this is on the left-hand side here. You see my primary elements for the workflow when you work with the data. And this workflow is set up from the perspective of getting attribution or credit as a data provider. So you generate and collect the data, you quality control and document the data. And I think if you can combine these two first steps, that makes life easier for you in the long term. So if you can embed at least part of the as a part of the documentation into the generation of data, whether it's a model or it's remote sensing or it's observations, that will help you later in the process. It's the analysis of the data, then it's preparation and publishing of the data through a mandated archive. And the reason why we say mandated is for the long-term preservation of the data. But in this step, it's very important to get a DOI, or a persistent identifier, for your data set. I could say persistent identifier instead of DOI, but DOIs are more or less the de facto standard that is being used today, that have the best services around the data sets for this purpose currently. That being said, it's not the only persistent identifier you can have for data sets. And for example, the Earth System Grid Federation are not relying on DOIs, but on handles. But that's probably too technical for the discussion here. Then I would say that everybody should write a data paper. And in the data paper, you cite the data sets that you got a DOI for in the previous step. And then finally, you write your scientific paper, citing your data paper. And through this, you have a workflow making sure that first of all, we can share data quite fast. Second, that you get credit for all steps that you're doing on the data. So a question that often arises when we speak about data management is why don't we let Google handle the data management? So first of all, Google do not do long-term preservation of data. So that's the first thing. The other thing is that Google is quite good at unstructured data, but science is actually based on a shared terminology. So actually agreeing on the terminology is quite important in order to be able to understand the context of the data. Google do not enforce any standardization of documentation and formatting. And this is necessary if you want to have services on top of the data. For example, for SIOS, when you have the SIOS core data, you need data to be standardized in order to build efficient services on top of the data. You want to say something, Darek?
Sorry, I have just a question on the chat for the Arctic Summit Science Week. No, I don't want to add anything.
I just saw that you raised your hand. So.
No, I was just ending the session at the Arctic Science Summit Week and just have a final words there. Sorry.
Multitasking, that's good. Yeah. And I think it's quite important in this context to remember that standardization has been the foundation for the WMO, for example. The WMO, the World Meteorological Organization, has exchanged information about the weather and the ocean and the cryosphere and hydrosphere for decades. And the foundation for this is standardization of the documentation and formatting of the data. It's the same for the Global Biodiversity Information Facility. It's the same within the in various ocean communities as well. So if we do follow this, we can actually take benefit of the computers and let them do part of the job for us. And an important part of documenting your data, and the purpose of documenting your data, is basically to establish a context around the data. And what we would like to do here is basically to say, you say that you have a temperature, but the point is also, which type of temperature? Was it collected in the soil, in the ocean, in the atmosphere? What was the units for it? What was the missing values for it? What was the instrument that was used in order to collect it, etc. And the reason we do this, this information makes structured data management different from the Google approach, which is basically unstructured. And when we do this, we then have the thing that do help us in this context is types of metadata, or different types of metadata. So metadata is data about the data. And for us now, I think it's within SIOS, we see that there are at least 3 types of metadata that are quite important. We have the discovery metadata, which is basically used in order to find the relevant data. And these data are like the index cards in a library. Then you have the use metadata that enables a user to properly understand the data that we found. So how to interpret the data. In addition, SIOS is working quite hard on the site metadata. So that's the observation facilities catalog that you can also access through the SIOS Data Management System, which for observations would be part of the use metadata. So linking this information enables users to properly understand the data and the context of the data. So I did say that metadata, that's data about the data. And the reason why we do this is that it enables people that do not know the details of the data collection or data generation process to properly understand the content of the data. So it addresses the point of finding, evaluating, understanding, and reusing the data. I did mention that discovery metadata, that's for the proper search of data. So the most relevant analogy is the index card in a library. And in fact, most of the standards that we are using today within modern distributed data management are actually old library standards that have been adapted to a modern age of describing data sets instead of books. So I think I will skip a bit fast through these slides. So the purpose is just to make it easier to find the data. It's also important to remember that discovery metadata is the key to filtering of the relevant information. So good discovery metadata is what we use in order to filter out the relevant information when you do a data search in the data portal. The use metadata is basically in order to understand the content of the data. So having set the scene for this, I think it's time to go into the FAIR guiding principles. And these are general rules that helps us build systems, proper data management system in a distributed manner. So these are the principles that we need people to follow if we want data centers to be able to communicate together and to bridge information across the data centers. And this is what we try to do in SIOS. So FAIR, that's findable, accessible, interoperable, and reusable. And there is a number of high-level elements that are listed here, but I think what is important for me to stress is that the elements that are colorized with yellow here. So you need a globally unique and persistent identifier for each data set. The reason for this is that if we harvest information from multiple sources and the same data set can be pushed through multiple sources or multiple pathways, we use the identifier in order to remove duplicates in the system that we set up. So for SIOS, this is important in the sense that there are some data centers that are also aggregators of information from other sources. So if we want to remove duplicates for that purpose, we need each data set to have a unique identifier. One example of this is, for example, in Norway, where both NASK, MET, and the Norwegian Polar Institute are sending information to the Institute of Marine Research for entrance into the Norwegian Marine Data Center. At the same time, SIOS is harvesting information from the Norwegian Marine Data Center, but also directly from NASK, MET, and NP. And then we can get the same data set through multiple paths into the SIOS system. And when we do this, it's actually quite important to be able to remove the duplicates in the pathway. And then the other thing on the findable is that the metadata or the data sets are registered through the searchable resource. And this is a searchable resource is actually the SIOS data management system in this context. To be accessible, that means that data are retrievable using the identifier through a standardized communication protocol. This is quite straightforward today, and it's already supported in the SIOS data management system. So the F and the A is quite straightforward, and I think most data centers are quite mature in this context. The important thing for a scientist is to know whether the data center that you're using is actually sort of supporting these elements. To be interoperable and reusable, I think that's where the major challenge are for most of the data centers and also the data providers, because then we enter into the use level of the data, so the actual data. So we're not talking about index cards in a library anymore, but this is actually the content of the book. And then it's important for interoperable to say that the data use a formal, accessible, shared, and broadly applicable language for knowledge representation. So these means standards. You have to use standards. Saying also, metadata and data use vocabularies that follow the FAIR principles. Using vocabularies meaning that you are using a shared terminology that the communities have agreed on, that is machine readable, and that we can use in order to do translations between the various sources or communities. And that data and metadata include qualified references to other metadata. And this implies, for example, for the data sets to link directly to the observations facility catalog, so that you can say that, okay, I got some temperature measurements from Svalbard. It's from Verlegenhuken, and here's the description of the weather station that has been set up at Verlegenhuken. It describes the instruments, the surroundings, the soil characteristics, the operator, calibration procedures, etc. So it's important information. When it comes to reusable, the far most important part is always to publish your data with a clear data usage license. And the recommendations in the SIOS data policy calls for the application of the Creative Commons attribution license. So that is actually compliant with the European law. It's been tested against the European Database Directive and other things. So that is quite useful. And never, I would say, never release your data without a clear license, because then it's confusion among the user community on what they are allowed to do on the data. And I think for most of the data providers in the SIOS context, actually having the attribution is far most important, because that gives you visibility as a scientist. Provenance is important. There are no good standards for it, but you could embed it into your workflow or into your data publication, or even into the history of structured file formats like NetCDF, CF, and things like that. Of course, then it's also important that metadata and data meet domain-relevant community standards. And this is the things that SIOS has been focusing on, with a recommendation of a few specific file formats for encoding of data. This being said, it's quite important to understand the full context of FAIR. So it's all 4 letters. Most people today think about the first 2 letters, the findable and accessible, and they forget about the interoperable and reusable. And the details, the devil is always in the details. For interoperable and reusable data, it's about the encoding, the application of standards concerning control vocabularies, etc., structures for the data, and licenses. So that's quite important. So FAIR guiding principles applies to both discovery metadata and the actual data. So both at the discovery and the use level. So yeah, so this I already said. So remember that FAIR is not only FA, so findable and accessible. One thing that is quite interesting in this context, and we've had that on a number of occasions when you have discussions about FAIR, there is a number of, call it myths about FAIR. I've had my own slides for this purpose earlier, but I found a very nice web page that you can look through if you want to in Denmark a week ago, something like a week ago, which have a number of questions around FAIR. So you have the questions like this, and then you have the answers below here, and you can go through these, and you can look at your own, challenge yourself, and look through the questions and the answers that are available here. I found this a very good one. I have the same questions from much of the community correctly when I speak about FAIR. And the address for this is given here. So it's the Danish Dike Consortium that has set up this, and there's quite some good information in that webpage, all in English, of course. I would like then to move on to some expectations on scientists. So I will go through this, then we can have a small discussion.
Øystein, okay. No, it was just some delays in showing the slides.
Okay. So what I try to say is that I will go through the next session, then we have a brief discussion before we have a small break, and then we go into the data management plans as the last part. So expectations on scientists, and if you want me to speed up, you just tell me, and then I will speed up on this. I always use the 5 P's matter, quoting basically Ruth Jure. This was actually an old slide for ESIP material, and I think it's still very valid, and it's a very good slide. Prior planning prevents poor performance. So the error that many people do is that they think about publishing the data once they have done their analysis and everything. If you think about publishing your data when you start data collection and quality assurance of your data before you do your analysis, you are much better off, because then you have a workflow that is based on the FAIR principles and well-documented data. This will also simplify the process for you, as there are many tools available today that are useful in order to work with the data in a proper manner. There are also some elements on best practices. Always document and share your data using standards. So these standards is always important. You can solicit feedback from data users and address identified issues. I've recently been involved with publishing YOP SiteMIP data for the Year of Polar Prediction model intercomparison experiment. And I got feedback from especially a group in France that had done numerous updates to their data sets in dialogue with the user community, as they discovered errors in their own data sets when they established the dialogue with the user community. So it's very useful for the scientific process as well. Important steps to think through when you are in the process of both preparing your data but also planning and documenting your data is how do you structure your data? And these have numerous aspects. I think some of them are easier discussed when we do the session on NetCDF, because then it comes quite evident out from that discussion. But one thing that is important to remember when you start documenting your data is granularity. How do you define your data set? And one challenge is that most scientists or most data providers think of their own usage. But if you take one step back and think of data users or data consumers beyond your own community, then you sometimes change the way that you document and share or publish the data. One example, for example, would be that if you do CTD casts on a cruise, in a research cruise in oceanography, the observational oceanographer is usually interested in the cruise. But, for example, a modeler would not be interested in the cruise, but in the individual CTD stations, because they want to use them for either assimilation or quality control of the models. So actually granularity is quite important, and how you to build your data set. That's quite important. Semantic annotation of the data, so conventions for naming variables in a consistent manner. Always use standards for that. And of course, then it's the physical encoding of the data in a file format. And this is, there are many containers that do exist. We do recommend for most data using NetCDF following these climate and forecast conventions. So it's a misconception that NetCDF is a structured format. NetCDF as such is just a container, like a comma-separated file or an XML file or a JSON file. When you add the CF convention on top of it, then you have a semantically consistent representation of your data. And then you apply the, comply with the fair guiding principles. So always choose and adopt community accepted standards. There is a lot of effort that has gone into these standards. If you try to do the same on your own, you will probably forget something. And there are tools that help you actually read and use the data afterwards. And the goal of a good data format is to make it easier for others to read the data, not only yourself, but you will benefit for this on your own as well. Yeah. The important thing here is that quite often I hear that people say, but NetCDF or some other standard doesn't fit my data. And then you develop something else, or you say that we need another standard. If everybody develops their own standard, there is nothing like a standard in the end. So instead of reinventing the wheel, always address gaps in the standards that do exist. There are governance structures around most standards. If you follow those, then life is much easier and you can close the gaps. For SIOS, it's quite important that if you find gaps in the standards, please tell us and we will help you with closing those gaps in collaboration with the governance structures of the various standards. For now, we probably have most knowledge and competence in the NetCDF, CF, or the Climate and Forecast Convention and ACDD. But we do also have people in the community that have much knowledge of the GBIF, also biodiversity standards as well. Use self-describing formats. The reason for this is indicated here. You have a structure of a NetCDF file here, for example, which tells you have different sections. You have the dimensions of the data sets. So what are the dimensions spanning the data sets, whether it's time and space or something else? The variables in a consistent manner, global attributes that can be used for different purposes, for example, the discovery metadata, and then you have the actual data values below here. So this ASCII representation is actually an ASCII representation of the binary file that is a NetCDF file. And this structure, there is a number of tools that help you move between the binary representation and the ASCII representation of the data sets. For SIOS, biological data, the recommendation is Darwin Core Archive for geophysical data, meteorology, oceanography, cryosphere data, etc. NetCDF adhering to the Climate and Forecast Convention, meaning that there are exceptions from this. There are data that do not fit in this model. Those data, probably some open data format with a comprehensive product manual that enables people to properly understand the data. This won't work for the SIOS core data though, but that's a different discussion. This way we are able to identify variables in a fair manner, units, missing values, aggregation levels, for example, whether this is a temporal average over a day or a month or a year, whether it's a spatial average over a grid cell or an area and things like that. Everything you can embed into a proper format for the data. Yeah, I think we've said this before. One important thing here is that for all the data that you work with, if you put a date into it, always use the ISO 8601 approach. For example, this is a proper way of putting in your data if you put it in a textual form into your data set. Year, oh, sorry. That was quite interesting. Then I will just need to find the proper slide again. Sorry for that. Year, month, day, and then you have the time afterwards. So it helps sorting out information. Other formats will complicate this. Also, if you want to put dates in or times in file names and things like that, always use the mechanism of year, month, day approach. So then it's easy to get help of the computer structuring the data when you work with them in a computer system. However, the most important thing is that no standard is perfect and gaps are found in all standards. As I said, mentioned earlier, those gaps should be closed. Do not invent your own standard. Do not invent yet another standard, but ask for help and ask for closure of the gaps. Finally, just a very brief note, because I only have 2 slides on this, is some nonsense legacy tools that may be useful. I know that a number of people are working with spreadsheets. Within the nonsense legacy, this information is available. I know it's probably too small for you to read, but you can find it in the SIOS website under Services and Data Management. There is a menu item for the nonsense legacy tools. Many people work with spreadsheets. Unstructured spreadsheets are a nightmare. This mechanism do actually have this toolbox have a mechanism to generate a Darwin core compliant spreadsheet. So you get an Excel spreadsheet afterwards with some quality control generated internally that helps you structure your data in a more sophisticated manner. You have information here in the which elements that you can add to the spreadsheet, and the output you get is a spreadsheet like this, where you for each cell have guidance text in the cell on the expected input, and there is some quality control on the input entered into these elements. It's not perfect yet. It can be further evolved, and SIOS is contributing to further develop this setup. But for people that do work with spreadsheets, I think this is a useful approach in order to use. It's a strictly column-based spreadsheet, which simplifies processing into other formats afterwards. So whether you want to embed it in a Darwin core archive or you want to generate a netcdf file from it afterwards, it's actually possible to do both quite easy. I think the most important thing today is basically that funding agencies increasingly require data management plans. And even, for example, if you want access to some infrastructure systems, for example, in Norway, if you want access to the infrastructure for research data or the computing system, you need a proper data management plan so that I can do planning of the resource evaluation, sort of resource investments. So a data management plan is a document describing what you are going to do with your data. So which data you are collecting and what you're going to do with the data, both during the project and after it's over. And it should also end up in ensuring that your data is safe for the present and the future. As I said, many funding agencies require data management plans today. So now I'm reusing a slide from ESIP, as I mentioned, from Ruture. And in the US, it's been quite in place for quite a few years. In Europe, you have to do a data management plan if you do a Horizon 2020 project. And also for the Horizon Europe, you will be required to put in a data management plan. In Norway, we also have to submit data management plans now for Research Council projects. And for the national infrastructure, access to the national infrastructure in Norway as well, we do have to set up the data management plans. However, the way this is done, currently, it's not necessarily evaluated as part of the proposal, but it's just something that you have to have there, and you have to put some statements in there. And unless you are actually violating some general rules, then it won't, they won't look too much into the details of it. But the tendency from the funding agencies is that we are moving towards an environment where the data management plans will be part of the evaluation of the proposals. So that's the background for this information. So there are information already available on the internet, for example, for Horizon Europe or for Horizon 2020. There are no dedicated, at least I checked last week, I couldn't find any specific requirements for the Horizon Europe setup. It was still the old Horizon 2020 references that was available in the European web pages. Yes, but the general concepts, regardless of whether you are in Norway, you're in the US, or within some European Union project proposal, it's the same basic elements of a data management plan. So the primary components of a data management plan includes information about the data and the data format. So which data are you collecting and how do you encode them? The metadata information, and in this context, it's also both on the discovery level and at the use level. So you need to think through both of them. Many people forget about the use level and only think about the discovery level. It's the policies for access, sharing, and reuse. So which licenses do you want to use? And the typical way of doing these elements, you know, is that you put up, you write a data management plan as part of your proposal, where you have some initial things that you put in. But then this is a living document that evolves through the lifetime of the project. So you add, remove, you add text or elements to the data management plan. It should also include information about the long-term preservation of the data and how you do data management, roles and responsibilities, or who's responsible at the top level for data management within the project, but also what are the responsibilities of, for example, principal investigators of different tasks within the project. And it should have part of some element on the budget, whether you put that in the data management plan or you put it in the proposal. I think in Europe, at least in Norway and for Horizon 2020, it didn't have to be in the data management plan. The important thing is that you think through data management in your proposal and that you add a sum for data management, proper data management in your project proposal. That's valid both for Horizon 2020 and Research Council projects in Norway. And data management now is an eligible cost in both these type of projects. How this works in other national programs in Europe, I'm not sure on. I don't have information about that. When you come into the information about the data and the data format, so you should add some information about the data that you're producing in the project, which type of data, the number of data sets. I would also normally in this section put in information about who's responsible for the data. So, and for example, things that you should indicate is whether these are experimental, observational, raw or derived data, physical collections, models, simulation outputs. Although it could be in other contexts, which is not necessarily relevant for SIOS, but it could be social social science data, etc. How will data be acquired? Also when and where? Also which regions do you set up? How will data be processed? The software that you're using, algorithms, workflows, file formats for encoding of the data, naming conventions. So if you follow FAIR guiding principles and use FAIR file formats, much is done in this context, and it should also contain some information about the quality assurance and control that you are doing. Whether you're using or reusing existing data is quite important to put in there, and also how you manage data in both short-term and long-term. So this is also about the versioning of the data, which is becoming increasingly important. If you handle data, how do you ensure the integrity of the data throughout the project? So can anybody mess with your data and change the content of the data? And again, responsibilities that was mentioned earlier. When it comes to the metadata content and format, it's about standards, referring specifically to the standards normally. So it's data about the data, context information, and it's both information for discovery and use of the data. Yeah. you can, of course, also there are minimum standards for metadata, but you can, of course, extend it if you think it's wise to extend the metadata for your specific purpose in the project that you're working with. Yeah. When it comes to, I think the important, also in a data management plan for a project, you have to specify the standards that you're using both for the discovery and the use metadata. For the discovery metadata, it's probably something that you need to discuss with the responsible data center for the data that you're using in the project, if that is part of the project or not. So you can, of course, run your project without having a data center affiliated with the project, but then you need to set away funding so that you can support the data center that will take over the data at some point. Important thing to remember here is that long-term preservation and publication of data sets cost. It costs money. And the larger the data set, the larger the cost. So remember to set aside funding for proper data management within your project. I think in the future, the tendency is also moving towards user contribution to data centers, in the sense that projects that do have data that I would like to deposit will have to pay a fee at some point, because with the open data policy of the European Union and most scientific communities, there will not be money charged from the data consumers, but it's more on the data producers that would have to pay off for this. Also, you need to remember to put some information about policies for data access, sharing, and reuse. And this is also then depending on the requirements of the funding agency, for example. It could, so requirements from the funding agency is one aspect of it. Requirements from, for example, the scientific journals on data preservation is also an important aspect there. So you need to sort of have an idea on these aspects when you write your data management plan and in the preparation of your project. How long should you, also lifetime, have a life cycle for the data or life cycle management? How long should your data be available for? And after that, a while, should they be cold data removed from the internet? Or should they go into some, should they be deleted after a while? For example, some of the numerical simulation data can be deleted after, say, 10 years or something like that. That's quite normal for in many contexts. For observations, this is much more difficult because you cannot redo an observation. So you have to think through what, when you have data, can some of the data be deleted after a time period? If data are not deleted, do you have to take care of all the data, or can you take care of a subset of the data? That contains the important information. And of course, it's considerations about ethical and privacy issues with data sharing. Again, this is much more relevant for social science, but also for natural sciences. For example, when it comes to species listings and information about species in certain regions, etc. It's also quite common that hydrological information has some privacy issues when it comes to data sharing and data publication. Here's one element about, furthermore on data. This is about intellectual property and copyright issues. First of all, it says here, this is a slide from Data One, taken from Data One, who owns the copyright to data, institutional policies, funding agency policies, etc. In Europe, as such, ownership lies with the institution and not the individual scientists. So that's one thing that is quite important. Furthermore, there is no copyright on data as such. You can have a copyright on a data collection, on a database system, but not on facts. Facts are not copyright in Europe, at least, with the nations that have signed the European Database Directive. So this is quite important to remember. Still, you have rights to the data. Still, you have the ownership to the data, but you need to think carefully through the wording in this this context. And also you should think through who are the future users and uses of these data. Citation, I think, is much well handled today. So have the DOI, then you have the citation information for the future, regardless of whether you have to delete your data if it's a numerical simulation, or if you can do, it should be a persistent data set. You also need to think through the preservation of the data set. So this is both during the period, but also the period after the project, during the project period, and also after the project period ends. And for archival, how do you handle it? Is archival meaning that you take it away from the internet, or do you make it available after the period after a time? Data transformations, also long-term preservation, also require, so most data centers that offer long-term preservation of data sets do have some requirements on the file formats that they can serve, because they have to maintain the integrity of the data throughout the lifetime of the preservation of the data. So you need to discuss with the data centers that will host your data. If you look into the file formats like HDF and NetCDF and a number of other formats, these are more or less independent of time, since these are the foundations that NASA and NOAA, for example, are using for their archives. So they will be sustained for a foreseeable future, as the large archives are based on these data. And it's, again, responsibility that you have to take. So you need to outline the roles and responsibilities for handling the data. So the information, also who is doing which parts of the data management plan, and it's not only the data manager of the project, but it also should involve the individual principal investigators. And it's usually a good rule to keep much of the handling of the data as close to the principal scientist or to the scientists as possible, since they know the data best. And then you can give guidance and help with tools and things like that from the data management side on the data. Budget, we did cover that earlier. I think some tools that you can use. This is just one of the tools that I've got best experience with myself. It's the DMP Online from the Digital Curation Center in the UK. It's quite nice. It has a different number of possibilities to handle the data. You can generate a template that you can continue to work with within a word processor if you like to do that. You can also download a machine-readable form in a form of a JSON file or something like that. So it's quite powerful. And as you see in the here, I got it. In the template, you have some information about the project details. You have the overview of the plan. You write the plan. You can share it, so you can have you can share both this one and the ECDMP. You can share within a community, so you use the online tool in order to write the plan, or you can actually download it and continue to work with it in a word processor. This functionality is slightly less mature in the ECDMP than in the DMP Online. And then you have, of course, the guidance on which elements that you should have in your data management plan. So when you do write your plan, you do get guidance material all the time on the elements that you should remember to keep in your plan. And both the ECDMP and the DMP Online are actually recommended by the European Commission for the Horizon 2020 projects. And most of them are basically referring both the ECDMP, which I'm showing an example of here, and the DMP Online are actually referring much to the Science Europe template for data management plans, with some modification into specific Horizon 2020 templates or specific project templates. Both EasyDMP and DMP Online are available through multiple data centers or services in Europe. For example, EasyDMP, this is from the Norwegian implementation of EasyDMP. There is an implementation in Belgium, in Germany, I think, and as a number of nations have data centers offering this functionality. Same with DMP Online. So not all nations have services around this, but many nations have services around these data management plans. So just to list some more tools for creating data management plans. So I did mention them the DMP Online initially. So this is the one that I've got most experience with, that I think is most mature. DMP tool is a US tool. I've never used it directly. It looks quite easy to use. EasyDMP is available, and it's maintained through the EOSC environment as well in Europe. I've got some reluctance to parts of the EasyDMP, which I think is not that easy to use as the DMP Online. For example, if you want to continue working with the data management plan through a word processor, like you create the template and then you further develop it using a text-based format. That is not straightforward, at least with the Norwegian implementation of EasyDMP, but that could be different in other countries. So that's something that one needs to discuss with the node that one is using for these different tools. Yeah, and this is just further information from the some further screenshots from the DMP Online element. I don't know how much more details I could give in this context. I think I've addressed what you really need to think through when you write a DMP. I can highly recommend this DMP Online because I've been using that for many years myself. It has good guidance on the information that you need to embed in a data management plan. And it's quite easy to get a user account and to continue to work and share with data there. The way I normally work with these systems is that I generate a template, I download the document once I've generated the template with some basic information, and then I continue working with the data management plan in an ordinary word processor and share it with the people I'm collaborating with. That's probably the easiest, the way people work on these things today. So this completes what I intended to say for the data management plans. Are there any